Okay, so just a reminder to everyone, remember that when I am talking, you're not, same as with the substitute here. So I need everyone to be quiet while I'm going through all of these notes. And if you have questions, the video can be paused at any time and you can talk about the questions that you have. Okay, so today we're talking about powers and exponents. And exponents and powers, same thing, it's your number up here. Whenever you are dealing with exponents, in order to combine them or simplify, they need to have the same base. In this case, we are talking about base A. So if you notice here, they both have base A, so you are able to add them together to get a to the n plus n. For example, if I had a to the third power times a to the second power, since they both have the base a's, I could get a to the 3 plus 2, which makes a to the fifth power. When you are dividing powers, you'll more often see them like this as a fraction, a to the m divided by a to the n. And when you are dividing powers, with multiplication we add, division's the opposite of multiplication, so what is the opposite of adding? Subtracting. So we end up getting a to the m minus n. Now to show you the long way here, if I had a to the fifth divided by a to the second, well, the short way is a to the 5 minus 2, which would give you a to the third. The long way is that you could write out 5 a's on the top, 1, 2, 3, 4, 5, divided by 1, 2, and you would cancel them out one for one. If they match, one matches on the top with the bottom, you cancel them. And notice here you're left with 3 a's, which is a to the third. So that is how that works. Now when you're dealing with properties of powers, you have powers to powers. And I know we've talked about this before, but powers to powers multiply. So we get a to the m times n. If you have parentheses, remember that the parenthesis means that this power is touching everything inside of the parentheses. So when we distribute that through, we get a to the m power, b to the m power. Okay, if I had something like this, 2 to the third power, oops, I want to take that parenthesis out, 2 to the third power raised to the fourth power. Okay, so I have 2 to the third power raised to the fourth power. These powers to powers multiply. So you end up with 2 to the 12th power. Okay, the long way is this 2 to the third power, you have that 4 times. You have 2 to the third times 2 to the third times 2 to the third times 2 to the third. And then we know that if you have the same bases, you can add all those up, and 3 plus 3 plus 3 plus 3 ends up making 2 to the 12th. So the short way is just knowing that powers to powers multiply. Okay? And same thing if you have an exponent on the outside, that needs to go to each term inside. Same thing with fractions. If you have a over b raised to the nth power, that nth power needs to go to everything that the parenthesis is touching. And that is how you end up with a to the nth power over b to the nth power. Okay, negative exponents, and there's a typo here. This exponent should have been right here. But with negative exponents, you cannot have negative exponents in your answers. So anytime you have a negative exponent, you need to change the side that the exponent is on. And what I mean by side is when you're dealing with fractions. So if I had a to the negative n power, I can always put that over 1. And in order to get rid of that negative exponent, I need to take that and move it to the opposite side. So I end up with a to the nth power in the denominator. And if there's nothing on top, there is a 1 on top. You can also go backwards. So if I have a negative number, or a negative exponent, sorry, down here, I can take that and move it to the top, and it becomes a to the positive n power. When you are dealing with reciprocals, or you can actually do reciprocals here if you have a fraction. So if I have a over b to the negative n power Remember, this negative is touching everything inside. Well, instead of distributing this negative n to this, and then having to flip both the top and flip the bottom, anytime you have a fraction, it just ends up becoming the reciprocal, and you end up getting b over a to the nth power. And then don't forget that you end up distributing that to both terms, and you get b to the nth over a to the nth. Okay, with zero, anytime you have a zero in your exponent, the answer is 1. How that works is if I had, let's see here, a to the third power divided by a to the third power. Well, we know that when you're dividing, you can subtract. So I have a to the 3 minus 3, which is a to the 0, okay? And I'm telling you that that equals 1. Well, why that works is if we do the long way here, and I wrote out a times a divided by a times a times a, remember that you can reduce these 1 for 1. So these all cancel out like that. Well, when they are canceling, they're really becoming 1s. Well, 1 times 1 times 1 divided by 1 times 1 times 1 equals 1. So that is why anything to the 0 power equals 1. All right, now we're going to move on to examples. Okay, so example 1. All we're trying to do is simplify and put everything together that we can. So here I have 2 and negative 4, and so I can multiply those together. 2 times negative 4 is negative 8. Okay? Next I go on to my a's. Here I have an a and I have an a to the third. Well, again, these are multiplying, and if this a doesn't have an exponent, we know that it's a 1. And if we go back to our rules, when you're multiplying, you add exponents. So 1 plus 3 makes a to the 4th power. Now we have our b's. We have b to the 2nd and b to the 3rd. If we add, 2 plus 3 makes 5. And lastly, c did not match with anything, so we just write it at the end. And that is my answer. Example 2. I have x to the 11th power divided by x to the 5th power. What we do here is all we have to do is subtract. So I take x to the 11 minus 5, and 11 minus 5 is x to the 6th power. And that is my answer. All right, moving on to example 3. On example 3, I have y to the 20th divided by y to the 30th. So y to the 20th divided by y to the 30th. If we subtract these, I get y to the 20 minus 30, which is y to the negative 10 power. Well, we can't have a negative exponent, so I can put this over 1, and to get rid of the negative, I take this whole thing and move it to the denominator. So I end up with y to the 10th in the denominator, and nothing's on top, so there's a 1. And that is my answer. A shortcut, well, I think it's a shortcut, is that anytime I have a dividing number, I know that I have to subtract. So instead of doing this right here, I'll just go, well, what is 30 minus 20, which is 10, and then because 30 is larger, I know that my y to the 10th is going to be on the bottom because it's going to stay on the side of the larger number. Because if I were to write 20 y's on top and 30 y's on the bottom, I'd cancel them all out and I'd end up having 10 on the bottom. So if you don't want to have to deal with negative exponents, just know that you subtract the two numbers and it stays on the side of the larger number. Okay, example 4. So in here, example 4, notice we have a negative exponent. Well, if you go back to our rules, remember that when you have a fraction with a negative exponent, all we have to do is flip it in order to make it positive. So if I go back here to this problem, and I have 1/3 to the negative 5th power, all I'm going to do is flip it, and it becomes 3 over 1 to the 5th power, and then I still have 2 to the 3rd to the 4th power. Now we also talked about with parentheses, anything that the parentheses are touching, this exponent needs to go to that. So when we go and simplify, we have 3 to the 5th power over 1 to the 5th power, times here I'm going to have 2 to the 4th power over 3 to the 4th power. Okay, at this point you could go ahead and do the powers, but you don't have to. There's a much easier way, and that is if you notice that we have a 3 to the 5th here and a 3 to the 4th here. Well, what do we do when we have a fraction? We can subtract the exponent. So that means there's 3 4s on the bottom. There's 4 3s on the bottom, and there is 5 3s on the top. So I can cancel out all of the bottom here, and then this, we just have 1 left over on the top. Also, 1 to the 5th is just 1, okay? And if we notice, the only thing now we have left is this 3 to the 1st, which is just 3, and 2 to the 4th. And so we would go ahead and multiply that out. So I have 3 times and 2 to the 4th power. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 3 times 16 makes 48, which is my final answer. All right, example 5. Notice that all of these are multiplying and they each have the same base of 5, which means we can add the exponents. If we go through and add them, I'd have 5 to the 2 plus 0 plus negative 4. When you add those, 2 plus 0 is 2, and 2 plus a negative 4 makes a negative 2. We are not allowed to have a negative exponent though, so we have to put that over 1. And we take this, switch it to the other side, and I have 5 to the 2nd on the bottom. If nothing is on the top, it is actually a 1. You want to simplify that by multiplying this out. So 5 to the 2nd power, 5 times 5 is 25. And that is your answer. Okay, example 6. Again, notice that we have a negative exponent with a fraction. The way we get rid of the negative exponent with a fraction is we need to take the reciprocal. We flip it. So at this point, I would write negative 6 x to the 6th y to the 3rd over 3 x to the 5th y, and this is now to the positive 2nd. So I just flipped that entire fraction. Now remember that you can only get rid of basically one of your negatives at a time. So the only negative I got rid of is this right here. This negative is not an exponent. You can have a negative number, you just can't have a negative number in the exponent spot, okay? So now we need to remember that we need to take this power, this 2, to every single term in this problem, okay? So I'm going to start here. When I take 2 to the, or negative 6 to the 2nd power, it's going to be negative 6 times negative 6, which is 36. Okay? Remember, powers to powers we multiply. So now I have 6 times 2, which makes x to the 12th. Here we have 3 times 2, which makes y to the 6th. This is over. Now we're taking this 2 to the bottom. 3 to the 2nd power is 9. Here we have 5 times 2, which makes x to the 10th. And here there's no exponent, which means there's a 1. And 1 times 2 makes 2. So we have y to the 2nd. Once we have that there, you need to reduce and simplify. Okay, 36 and 9. 9 goes into 36 4 times. Okay, and you can put the 1 there. Our x's have the same base, so we can reduce them. 12 minus 10 is 2, and it's going to be on the top because 12 was bigger, and this is now going to become a 2, x to the 2nd. Here we subtract. 6 minus 2 is 4, so this cancels out, and this becomes a 4, because again, 6 was larger. If you notice, nothing is on the bottom anymore except for 1. So my answer is 4x to the 2nd, y to the 4th. And you could put it over 1, but we know that that means exactly the same thing. So that is your answer. All right, moving on to example 7. On this problem, you have this negative exponent here, okay? And so, but I look and I know that a negative times a negative is a positive. So instead of making these fractions, it makes more sense to just go ahead and distribute our exponent through, because then I'm going to get rid of my negative exponents. Again, because a negative times a negative makes a positive. So I rewrite my 4t, and then when I take negative 2 times negative 1, it makes s to the second. Then here I go negative 3 times negative 2, which makes t to the 6th. At this point now, since I have no more negative exponents, we're just going to combine anything we can. There's no other numbers except for 4, so I have 4. There's no other s's, so I have s to the second. And then with the t's, I have 1 here and 6 here, so we add 1 plus 6, which makes t to the 7th. It's important to remember when you're writing your letters, you always want to write them in alphabetical order. Okay, so this is your final answer on this problem. All right, example 8. Okay, there's no way to get rid of this negative exponent on this one except for by moving it to the denominator. So here, in order to get rid of this negative exponent, I'm going to take this and move it down to the denominator. The y doesn't move though, because notice that this exponent is positive. So I'm going to have x to the third on the bottom and y to the second on the bottom. And since there's nothing left on the top, we write a 1. Over here, there's no negative exponent, so I'm just going to rewrite 1 over xy. Now we combined our terms that can be put together. And if you notice here, we have x to the third and x. Okay, so that's going to make x to the fourth. And then I have y to the second and y. Again, these were 1s. And so we add that, and we get 2 plus 1, which makes y to the third. On the top, 1 times 1 is 1. And that is your answer. Okay, moving on. Our last example for the set of notes. Since this negative exponent, if I brought it to the 6th, that would be a negative, this would make a negative, and then that would make a positive. So since by distributing this, I would make more of them negative exponents than positives, I would go ahead and just switch this whole thing to the denominator. So what I'm going to do is, in order to get rid of this negative 1 and make it a positive 1, I have to take this whole thing and move it to the denominator. So I'm going to write that now as 6c to the 4th, f to the negative 3rd. When I moved it, I'm not getting rid of this negative at this time because I'm only getting rid of this negative exponent here, and you can only get rid of one negative exponent at a time. So sometimes you're moving it down and then back up again, okay? Now this right here doesn't have a negative exponent, okay? So I'm just gonna go ahead and rewrite that for right now. So I have 3c to the negative 3rd, f to the 3rd, and this is to the 2nd power. Okay, and this one is now to the positive 1 power. And if there's nothing on top right now, there is a 1. Okay, my next step is to get rid of these exponents. Well, the 1, it's not going to change anything, so I still have 6c to the 4th, f to the negative 3rd. But the 2, when we distribute it through, and remember you need to take it to everything. So I'm taking it to 3 to the 2nd, which would make 3 times 3 is 9. Okay. And then I have c, and I have to the negative 3rd. So negative 3 times 2 makes c to the negative 6th. And then with the f, I have 3 times 2, which makes 6. And again, I still have a 1 on top. Now, notice in our denominators that I have multiple c's and multiple f's. I would go ahead and add them together before I start moving them around, because sometimes the negatives may cancel out and you don't have to move anything. So at this point, we are going to go ahead and put some of our numbers together. We can multiply 6 times 9, and 6 times 9 is 54. When you do this, we have 4 and negative 6, which will make c to the negative 2nd power. And then we have negative 3 and 6. When you put those together, 6 minus 3 is 3. So I have f to the 3rd. So notice that this c was still negative, But with the f's, when I added those together, it ended up becoming a positive 3. At this point, we need to remember that the only thing we can't have that's not simplified is you cannot have a negative in your exponent, or a negative in the exponent. So I take this c, and that's the only thing I have to move up. So now when I move that up, I'm going to have c to the second power. It becomes positive because I moved it. And then I have 54 f to the third. There is nothing else that can reduce, so this is my final answer.